Okay, another property for supremum and infimum says that in case you have two sets A and B, which are such that all elements of A are less than or equal to all elements of B, then in that case, supremum of A will always be less than or equal to infimum of B. So what are the sets that are we talking about? What are the type of sets that are we talking about? So let us try to look at it. What we are talking about is about sets such that all elements in A are less than or equal to all elements in B. So it's going to be a set like this, A and B. So all the elements in A are clearly less than or equal to all the elements of B. Now, supremum of A would lie somewhere here. Okay, supremum of A would lie somewhere here and infimum of B will lie somewhere here. And that means that supremum of A will always be less than or equal to the infimum of B. Okay, diagrammatically I've explained this to you. Now let's just try to prove it also. Let's mathematically try to prove it. So let us take, let B belong to the set B. Okay, any arbitrary B. Okay, let B belong to B. Now, so first of all, okay, what I've forgotten to write is essentially that we are given A is less than or equal to B for all A belonging to A and B belonging to B, and what we need to prove is that sup A is less than or equal to in B. Okay, so I beg your pardon, I forgot to write what I always say is the most important thing, given and to prove. Now, let B belong to B. So that would imply by what is given to us that B is greater than or equal to A for any A whatsoever belonging to the set A. And what does that imply? That implies that B is an upper bound of A, upper bound for A. B is an upper bound for A, and that would imply that B is greater than or equal to supremum of A, because sup is the least upper bound. So any other upper bound needs to be greater than or equal to that, right? So now B was any arbitrary element from the set B, right? So therefore we have that sup of A is less than or equal to B, right? For any B belonging to the set B, right? So which implies that sup of A is a lower bound for the set B, right? Because this is happening for every element of the set B, therefore sup of A is a lower bound. It's lower than each and every element of the set B. So that implies that sup of A should actually also be less than or equal to the infimum of B. Why? Because infimum of B is the greatest lower bound. Okay, infimum of B is because this is the greatest lower bound. Hence, we have proved what we required to.